Good day everyone, my name is Kristian Labayno from BS ECE 3A. Today, I will present my performance task number 6 at my ECE 23 subject. Let's start. Convolution coder rate 1/3. 1 is the input and the 3 is the outputs. The topics are transistor table, state machine diagram or state diagram, and the treeless diagram. In this picture, we can see that this side is the input side and these ends are the output side. There are three because of the rate. One is the input and the three is the outputs, and the one m are the current state. Let's proceed. Convolutional coder, it is a differ from block codes in that the encoder contains memory and the n encoder outputs at any time unit depend not only on the k input but also in the m previous output. It is generated by passing the information sequence to be transmitted through the linear finite state shift register. Let's proceed. Transition table. In this picture, I have said before, this side are the inputs and this side are the outputs. These M's are the current state. The current state have 4 levels, 0, 0, 0, 1, 1, 0, and the 1, 1. This arrow is the shift registered and this symbol is the XOR. Therefore, the rate 1/3 is 1 bit input and the 3 bits output. This side is the input, these are the current state, these are the outputs, this is the next state, and these are the levels of input to the current state. We will take note that the N1 is equals to input XOR M0 XOR to M1, the N2 is equals to M0 XOR to M1, and the N3 is equals to input XOR to M1. We will going to have an example. For example, in this input is the 0. We will put in this, and the current state is 0, and the M1 is the 0. 0 XOR to 0 is equals 0 XOR to 0 is equals to 0. And M0 XOR to M1, 0 XOR to 0 is equals to 0. And 0 XOR to 0 is equals to 0. Therefore, the outputs of the given of the inputs are 0, 0, 0. This is it. We can see the next state by determining by we will put this input to the right side of M0, and this M0 we will going to the M1, and this M1 will be cancelled, and this D are the called 0, 0, 0. Other example, this one current state is 0, 0, and 1 XOR to 0, 0, 0 XOR to 0 is equals to 1. 0 XOR to 0 is equals to 0, and 1 XOR to 0 is equals to 1. Therefore, the outputs are 1, 0, 1. The next state will be 1 going to the input will go to the M0, M0 will go to the M1, and the M1 will be cancelled. Therefore, the current state is 1, 0. This is how the next state was going to be filled up. Let's proceed to another example. This level 0 Current state is 0 and 1. Therefore, 0, 0, so 0 sort to 0 and 0 sort to 1 is equals to 1. 0 sort to 1 is equals to 1 and 0 sort to 1 is equals to 1. Therefore, the output are 1, 1, 1. The next state will be, ang 0 will be going to the 0 or M1 and this 0 will go to the M1 and this 1 or M1 will be cancelled out. Therefore, the next level will be, we can get it. Therefore, we can fill up this table easily. Let's proceed. State machine diagram. In this table, the state machine diagram has 4 levels, the 0, 0, 0, 1, and 1, 0, and 1, 1. In this, we can see the 0, 0, 1, 0, 1, 1, and 0, 1. In this 0, 0, the next state will be 0, 0. Therefore, 0, 0 will going back to itself as 0, 0. And 0, 0 will go to the 1, 0. Therefore, this connect in this. And 0, 1 will go to the 0, 0. 0, 1 will go to this 0, 0. And 0, 1 and 1, 0 will go to this area. And 1, 0 is equals to 1, 1 will go to this. And 1, 0 will go to the 1, 1. 1, 1 will go to the 0, 1. Therefore, this is it. And 1, 1 will go back to the 1, 1 as it next level. Therefore, this is now the state diagram. The blue indicates the input and the red indicates the outputs. We must level it so that we can easily identify the output of the given current state and the next state. Let's proceed. The tree-list diagram. We can use the state diagram to fill up the tree-list diagram. In tree-list diagram, we use the 0. We will duplicate it, 0, 1, and the 1, 0, and the 1, 1. We can see this, the 0, 0 will return to 0, 0. Second, 0, 0 will go to the 1, 0. And the 1, 0 will go to the 1, 1. And 1, 1 will return to itself as 1, 1. And 1, 1 will go to the 0, 1. And 1, 0 will go to the 0, 1. And the 0, 1 will go to the 1, 0. And 0, 1 will go to the 0, 0. Therefore, we can get this tree-list diagram easily. This we will label always to easily identify the outputs of the given diagrams or the given convolutional codes. Summary: convolutional code is a type of error correcting code that generates parity symbol. Second, are the bits like the block codes that they involve the transmission of parity bits that are computed from message bits. And last, the tree-list uses a convolutional codes. I hope you have learned from my discussion. Thank you.